In this module, you will learn about the second law of thermodynamics. Earlier, you learned that the efficiency of a heat engine eta is equal to 1 minus Q2 by Q1, where Q1 is the heat absorbed by the system from a hot reservoir, and Q2 is the heat released by the system to a cold reservoir. If Q2 is equal to 0, then the efficiency of the heat engine is 1 or 100%. Such a heat engine is called a perfect heat engine. This means a perfect heat engine can convert all the heat absorbed into work without any transfer of heat to the cold reservoir. Can a perfect heat engine be constructed? No. Every attempt to construct such a perfect heat engine has failed. In fact, the reason may not be technical. It may be of fundamental nature. For example, if an engine can convert all the heat to work, it need not take heat from a hot reservoir, but it could absorb heat from its surroundings and convert it into work. If that were possible, a car engine could have taken heat from the surroundings and run the vehicle without burning fuel. In fact, the process of converting heat completely into work is consistent with the first law of thermodynamics. But it seems that nature has put a constraint on such processes. There are many such processes that are valid according to the first law of thermodynamics, but which do not take place on their own. For example, if we rub our hands, they become warm. On the other hand, do both the hands absorb heat from their surroundings and rub each other on their own? Consider a metallic box with two chambers separated by a partition. One of the chambers is filled with some gas and the other chamber is empty. If the partition is lifted, we all know that the gas diffuses to the other chamber. Can the diffused gas molecules on their own move back and occupy the first chamber only? That will probably never happen. Some of these processes do not take place because nature does not permit them to. Hence, there must be a law of nature that decides whether a given process, allowed by the first law of thermodynamics, actually takes place or not. The second law of thermodynamics is the principle of nature, which disallows certain processes from taking place, even though they are consistent with the first law of thermodynamics. There are many ways to state the second law of thermodynamics. One form of the second law of thermodynamics, which denies the possibility of a perfect heat engine, has been given by Kelvin and Planck. It states that no process whose sole result is to absorb heat from a reservoir and convert it completely into work is possible. There is another version of the second law of thermodynamics, which explains a fundamental limitation to the coefficient of performance of a refrigerator. Earlier, you learned that the coefficient of performance of a refrigerator, alpha, is equal to Q1 by W, where Q1 is the heat extracted from the cold reservoir, and W is the work done on the system. If W is equal to 0, then the coefficient of performance is infinity. This means a refrigerator with a coefficient of performance equal to infinity can extract heat from a cold reservoir and release it to a hot reservoir without any external work on the system. Such a refrigerator is known as a perfect refrigerator. But the second law of thermodynamics places a restriction on this. The other form of the second law of thermodynamics, which restricts the possibility of a perfect refrigerator, is given by Clausius and states that no process is possible whose sole result is the transfer of heat from a colder object to a hotter object. This means we can't make a refrigerator function without any external work on the system. Both ways of stating the second law of thermodynamics are equivalent. Any one form of the law can be logically derived from any other form. Let us assume that the statement given by Clausius is wrong, and there exists a perfect refrigerator that absorbs Q1 heat from a cold reservoir at temperature T2 and releases the same to a hot reservoir at a temperature T1. Let there be a heat engine working between the same two temperatures T1 and T2. Let us also assume that this heat engine absorbs heat energy of Q1 plus Q2 from the hot reservoir, does some work W, and returns heat Q1 to the cold reservoir. If we take the combination of these two, the net effect is the absorption of heat Q2 from the hot reservoir, which is converted completely into work W. We can have a perfect heat engine. That means that if one form of the second law of thermodynamics is violated, and the other form is also violated. The first law of thermodynamics is a statement of the law of conservation of energy, according to which energy can neither be created nor destroyed. Whereas the second law of thermodynamics restricts the availability of energy and the ways in which it can be used and converted. You have now reached the end of this module. In this module, you learned that the second law of thermodynamics is the principle of nature which disallows certain processes from taking place even though they are consistent with the first law of thermodynamics. Second law of thermodynamics, Kelvin-Planck statement. No process whose sole result is to absorb heat from a reservoir and convert it completely into work is possible. Second law of thermodynamics, Clausius statement. No process is possible whose sole result is the transfer of heat from a colder object to a hotter object. The second law restricts the availability of energy and the ways in which it can be used and converted.